All right, so for part B, some of this might look familiar from earlier. What we had done is we started with one substance here, silver nitrate, and converted that to our grams of silver chromate. We're going to do the same thing. All of these numbers are going to be the same, okay? That has not changed. The only thing that has changed is what we're starting with, okay? So notice we had 13.5 grams of silver nitrate. Now we're going to have 13.5 grams of sodium chromate. So then we put all that number here in a 2 CrO4, okay? Of course, this is the atomic mass for silver nitrate, so what we would need to do is change that to grams of sodium chromate. 161.97. I did that math in my head. No, not really. Mr. Wagner, help me out here. So I'm just going to abbreviate it as sodium chromate because we know that sodium chromate has this formula because we illustrated that right here. Then that's for every mole of sodium chromate. Then in this process, then for every mole of sodium chromate, we still get just 1 mole of silver chromate. And then again, this number does not change. So then once we multiply across, okay, what that will mean is now we'll be able to determine what's called a limiting reactant. So the only number, this number is still the same. This one will be different because the atomic mass is different. So I see you're punching that. 217?
27.65.
27.65. Okay. So then.
Because we didn't multiply by 2. So
right, but we still have that atomic mass there.
Yep.
Okay, so when we divide that into there, we get 27.65.
Oh, I'm sorry.
Yep.
So it would be 161.
Yep, 161.97. We're actually a comedy routine, you could say. So then here we get 27.
Yep, 27.65.
Okay. So when we had done this earlier, why did I erase that? This came out to 13, I think.
Yes, it was 13.
Yeah. So then what happens is if we start with 13.5 grams of silver nitrate, we produce 13 grams of the silver chromate. If we start with 13.5 grams of sodium chromate, we get 27 grams. So we get less of an amount when we start with silver nitrate, so that means this would be what we call our limiting reactant. We just wanted to illustrate that these numbers do actually mean something, and we'll briefly talk about that perhaps tomorrow for those of you who have made the choice to tune in. Okay, so I'm going to erase this, and we will go ahead and put a couple of examples on there. We have about 10 minutes left. Okay. We're making you a star.
Yes. All right, so for our first problem, we have zinc sulfate plus lithium equals, well, we don't know. But it is a single replacement as designated above that arrow there. So let's start with our zinc sulfate. We're going to have zinc, which is Zn, and then we'll have a sulfate ion. Our sulfite ion we know is a -2, and if we look at our periodic table, we should, zinc, which one's zinc? Got to pull up my periodic table. Oh, here's one. Zinc would be a +2. Okay. Oh, I made it way harder than it had to be. So it's +2. So, as we can see, our positive and our negative charges cancel out, so we don't have to have any numbers add to the problem. So then we're going to put a plus sign, and then we have lithium. No, lithium's a +1 because it's in the first column. So, because it's a single replacement, we know that our positive ion has to leave this sulfate. So if you remember, we can draw this line to show how it'll separate. So this lithium will now take the place of the sulfate ion, or of the zinc ion, and create lithium sulfate. So we have Li, which is a +1. Then we have a sulfate, SO4, which is a -2. And let's bring over our zinc, which will be zinc. We don't need to know it's a +2 over here, but I'll put it down just so we stay consistent. Okay. Now that I have the entire reaction written out, I have to make sure, well, oh shoot, forgot one thing here. Our charges here don't balance. So in order for this to become a +2, we have to add another lithium ion. So we can just simply draw on a 2. That 2 means 2 times 1 is +2, and then +2 cancels out with -2. So let's balance this out. So like we have done before, we can write down all our ions, and we'll keep the sulfate together because it does not break apart. So on the left side, we have 1 zinc. On the right side, we have 1 zinc. It is not diatomic because it is not a gas. Sulfate, on the left side, we have 1. On the right side, we have 1. So again, sometimes it will be outside of parentheses, but we know that it's a sulfate ion. So we can just either actually draw in the parenthesis lines or in our head just know that there's a parenthesis. Then finally, our lithium. On the left side, again, not a gas, so it's going to be just 1. However, on the right side, we now have 2 lithium to balance out the charges. So I'm going to write in our 2. So to balance out the equation, we now need our zinc's good, our sulfate's good, but our lithium is not balanced. So in order for there to be 2 lithium on the left side, we have to put a 2 in front of one of these. Well, we know that it has to be lithium, so we'll place a 2 right there. And that would make our lithium a 2. So if we look again, yep, it's all balanced. It's lithium's by itself, so we don't have anything else to change. So it would be, our final answer would be 1, 2, 1, 1. All right. Now let's finish off with our manganese, or our last problem. Excuse me. So in this equation, we have manganese 3 plus hydrogen chloride. So let's write manganese 3. It's Mn, which is +3. Because we know that because it has the charge right behind it and written in Roman numerals, plus hydrogen, which is just H, Cl. And we'll write in our charge for the hydrogen and our charge for the chlorine. Oh, not -2, -1. So everything's balanced over here. We don't need to add anything over here to our manganese, and our hydrogen and our chlorine balance out. All right. So again, this would be a single replacement as shown above the arrow, but we know this because there's 1 lone ion and a compound. So we're going to draw that line, if we need to show where our compound will split between the hydrogen and the chlorine. And we're going to switch our 2 positive ions. So again, hydrogen is positive, manganese is positive. So this manganese is going to hop in right there, and the hydrogen is going to come out the other side. So we'll have manganese, Mn, which is a positive 3, right? Manganese 3, chloride, negative 1. These do not balance out, so I have to add 3 chlorine plus hydrogen. However, it's a gas, so we have to make it diatomic, 2. All right, and then don't need it, but plus 1. So let's finish it out. So it's all balanced across the board. Now let's balance it. Mn, Cl, and H. So we have 1 manganese on this side, 1 manganese on the other. On the reactant side, we have 1 hydrogen. On the product side, we have 2 hydrogen. On the reactant side, we have 1 chlorine. And on the product side, we have 3 chlorine. So just going down our list, manganese is equal on both sides. We're good. Chlorine and hydrogen are not. So we'll have to get them to balance. And I can see that, if I do some quick math in my head, I can see that if I want to make this, say I want 3 chlorine on this side and I draw on a 3, that means I have 3 hydrogen on the left side. There's no way I can get 3 hydrogen on the right side, on the product side. So we can't do a 3. And we can't do a 2 either, because if I draw on a 2, yes, my hydrogen now becomes a 2 on the left side, but my chlorine becomes a 2 on the left side, and there's no way for this 2 to become a 3. So I have to find the least common multiple. And the least common multiple between 2 and 3 is 6. So it can't be 4 because 3 does not go into 4. It can't be 5 because 3 or 2 does not go into 5. So it has to be 6. So let's make it 6. So now we have 6 chlorine and 6 hydrogen on the reactant side. Well, now we have to balance out the product side. So in order to make chlorine to be 6, we have to add a 2 in the front. And in order to make our hydrogen 6, we have to add a 3 in front of the hydrogen. So we're 6. But when we added the 2 to the chlorine, sorry, I jumped around, but when I added the 2 to the chlorine, it made my manganese 2. So to make my manganese 2 on the reactant side, I have to put a 2 in front of it. And so, there we go. So now I have 2 manganese, 6 chlorine on both sides, and 6 hydrogen on both sides. So it's balanced. So our final answer would be 2, 6, 2, 3. All righty. That should be all for today. See you tomorrow.